This is Geometry Semester 1. It's a unit called Congruence. It's the third lesson called AAS, which stands for Angle, Angle, Side, Congruence Postulate Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So, before we get straight into the problems, let's show you that website so you can find the notes. Right? Okay, go here. Okay, here's the website name, creatormath.weebly.com. The home page should look like this when you get there. If you have any questions about your composition book, like composition books are due again right now, check this website, scroll down under the picture where it says composition book, right, in large letters, and has a picture. Please watch all these videos and follow their directions. Please look at all these turn-in dates and follow them and put all these things in this place and that place in the comp book, and you should have a 90 to 100 on your composition book, which should be a nice grade booster. And, of course, you need those notes to help you with a lot of these problems. So now I'm going to the Geometry tab. All of the notes, video lessons, and problem sets and vocabulary is under the tab of the course you're in this case, Geometry. Here's the Vocabulary Geometry Practice Study PDF. This has every geometry word we use for the entire school year, and it is searchable. You just have to Google, how do I search a PDF with whatever device you're working on. It's a little bit different for each device. Now we're scrolling down to the proper semester for the video that we're looking at right now. So this is the video we're looking at right now is this semester, and here it says Geometry Table of Contents. Your job is to copy every line of this table of contents into pages 2 through 6 of your composition book. You should have done that already. If you haven't, stop what you're doing now and please do that. There are videos on how to number your pages of your comp book and what great comp books look like as a model for you, okay? So I'm going to scroll down to the proper unit. So congruence, and it's lesson number 3. There are 5 lessons overall here. It's AAS, which stands for Angle, Angle, Side, Congruence Postulate. Here are the page numbers that these notes go on in your comp book. Please don't use this video, but look at the actual table of contents at the time that you are viewing this video. These page numbers could very well be different. Okay, so don't take this video's word for it. Go find the original. Here are the notes. You might have to click it twice. So there you go, mine loaded. Sometimes it doesn't, and I have to go back and reload it. You should be able to expand it like this. This will allow you to expand it. Whatever device you're on, you can now copy this into your comp book. All right, so given 2 triangles with 2 equal corresponding angles and an attached equal corresponding side, what can be said about the 2 triangles? Well, guess what? They are congruent. So this is called the AAS, Angle, Angle, Side, Congruency Postulate. 2 triangles with equal corresponding angles and an equal attached corresponding side. The 2 triangles are congruent. So just keep in mind that congruent means equal. It means they're the same exact shape and the same exact size, right? That is what congruency is in geometry. So here's an example of that. There's a side angle here, 1 tick mark. That corresponds to this one, 1 tick mark. Come to the right, and in this case it's 2 tick marks. Here's 2 tick marks, so those 2 angles are the same, and then there is a side attached to that next one, so it goes angle, angle, side. It's right next to it. If we have this situation for 2 triangles where the 2 angles and the attached side, not included but attached, are equal, then these 2 can be said to be congruent. Now, they're drawn out of scale on purpose to mess us up and make us use the actual postulate, AAS, Congruency Postulate, to determine that they're congruent. Here's an example. Copy that in your comp book. This is our 3rd lesson in the subject, but just to review some big issues. Similar is maybe said to be an opposite of congruent. Similar means proportional. Right, so we always bring out the model of the helicopter, right? This is an Augusta A109. It's a 1/43rd scale of the original helicopter, right? So this is what proportional means. This is a smaller shape, but exactly the same shape, just a different size. That's what proportional is. So that's similarity in geometry, not congruence. All right, congruence means equal. Similarity means proportional. The symbol for congruence is an equal sign with a squiggly over it. The symbol for similarity is a squiggly symbol, squiggly line. A postulate is a rule or definition, like a circle has 360 degrees. You guys, we made that up. We defined a circle to have that many degrees. That would be an equivalent of what a postulate is, a definition, right? And the contrasting word of postulate is theorem. A theorem is a proof using postulates and definitions, right? So this is a postulate we're working on now for congruency. Here's a couple examples. Put those in your comp book. Answer those if you can. Let's look at the problems they've given us. So question 1, what does congruent mean? So congruent means more than equal, equal corresponding angles, and equal corresponding side lengths. Congruent in geometry means same shape, same size. Okay, all aspects. And students say, why don't we just use equal? I always argue that congruency means multiple aspects of equality. It's not just the angles that are equal, all three of them, equal to each other in order, right, correspondingly. But it's the sides that also correspond that are equal lengths to each other too that make the two shapes equal. So multiple aspects of equality. What does proportional mean? That means larger or smaller by a scale factor, also called similar in geometry, like our model helicopter. Okay, that would be proportional, and it has a relationship of a scale factor. Remember our helicopter, right? It has a 1/43 scale. So we took every piece of the original, divided it by 43, and then put together this one, and now we have a perfect looking helicopter just like the original, but smaller. 1/43 the original. That's a scale model. That's proportional or similar in geometry. What's the symbol for congruence? It's an equal sign with a squiggly on top. What's the symbol for similarity? It's just a squiggly line. It means similar. All right, the following two shapes are congruent. They're going to tell us everything's congruent and then ask us why. So what's the reason? Well, let's look at corresponding parts. Side length equal to a side length. Next side length equal to a next side length. And the next one from that equal to the next one from that. This is a side, side, side congruency postulate that proves that these two triangles are exact same size and exact same shape. Right? They are congruent. And the reason is side, side, side congruency postulate. All right, this goes back to, this is the third lesson on this. So side, side, side congruency postulate was lesson 1. And they're going to ask us a bunch of these. The following two shapes are congruent. What is the postulate? Side, 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 side. Remember, this would be laid down in a similar orientation. Now when we compare it, this one's equal to this one's equal to this one, and this one's equal to this one. Side, side, side congruency postulate. This is telling us they're drawn not to scale. In other words, they're purposely confusing us as to whether these are the same size or not. We need to use the data. The data says this one's side's equal to this one's equal to this one, and this one is equal to this one. By the way, they're all three not equal to each other because this has 1 tick mark, 2 tick marks, and 3 tick marks, right? But it makes up a side, 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 corresponding with a side, side, side of another triangle, so therefore these are congruent. And the proof of it is, or the reason for why we get to say that, is the side, side, side congruency postulate. All right, the following two shapes are congruent. We have a side, and maybe we should just rotate this. Let's rotate this around. This is 5, that would make this 12, and if we rotated, this would be 7. So 5 corresponds with 5, 7 corresponds with 7, and 12 corresponds with 12. So side, side, side congruency postulate. Okay, 2 more triangles, not drawn to scale. Again, rotate this one over. It looks like this. You might have to change the orientation. The 5 would be here then, the 8 would be here, and the 15 here. Corresponding 5 with 5, 8 with 8, 15 with 15. And I'm going fast because this is going back 2 lessons now ago. So these are review. Side, side, side congruency postulate. All right. Now let's get up to lesson 2 where we did side, angle, side. So let's rotate this one around. so it's like this, that would put this angle here, 1, 2. That would put this angle, or this side length would now be here, 1, and this side length would come over here, 2. So corresponding length, corresponding angle, corresponding length. What we have here is a side, angle, side, and it's the included angle, the angle between the two sides, that is required. All right, so this meets that definition of side, angle, side. And check back with your notes to see where we define that, right? All right, same drill. They're giving us, let's rotate this. They all seem to rotate the same direction. I guess being consistent to help us as much as possible. That would put the 8 here. That would put the 15 here. And that would put this angle F right here. 1, 2, 3. So 8 corresponds with 8. Angle included between the two sides corresponds with this angle. And the 15 corresponds with this side. So this would be a side, angle, side congruency postulate. And this is one of those problem sets where they're really not, trying to trick us. They're not trying to really question us much, but just reinforce the meaning of these understandings of these postulates, all right? The following two shapes are congruent. By what congruent postulate are they congruent? Well, this is the same thing. If rotate this again, 5, no, the 5 would go, the 12 would be here, and in between here. Okay, so 5 corresponds to 5, 12 corresponds to 12, and the included angle corresponds to the included angle. Side, angle, side congruency postulate. One more. Again, if we rotated it and tried to track what's where, let's see, if I rotated this, this one's going to be 1, 2, 3. This is going to rotate all the way down to this side, and this one's going to be up here. Does it correspond? 2 tick marks, 2 tick marks, 3 tick marks, 3 tick marks, 3 tick marks on a side now, not an angle, 3 tick marks, yes. Side, angle, side, congruency postulate. All right. Purposely not drawn to scale. They look different sizes to trick us. All right. So are they congruent? Well, let's rotate this one and map it out again. This now correlates with this third lesson. So this one comes here, D. The next one around is E here. And that makes this side here 1, 2 tick marks here. It comes around to this one if we rotate this, right? So angle A and this angle here, they are the same measure. So they're corresponding and equal angle measures. B corresponds here to this angle, and they're 2 tick marks. They are corresponding and equal because 2 tick marks each. And this length now is 2 tick marks and 2 tick marks. So what we have here, and they're all in order or in line, they're all adjacent or next to each other. Angle, angle, side. Angle, angle, side. This is yet another congruency postulate. So triangle ABC is congruent to triangle DEF. This is the congruency symbol. Why? Because of the angle, angle, side congruency postulate. So here we go again. Let's see if we can map this one out. The D comes over here to this side. This F is over here, 1, 2, 3. And 8 comes over here. So now we're going this way around. We have an angle, angle, and a side. Do we have an angle, angle, side? And notice this is 1 tick mark, good. 3 tick marks, good. And 8. That is the definition of angle, angle, side. Notice it's the side attached to that second angle, okay, or included. The prior definition was not included but attached, right, is what I want to say. I do not want to say included. I want to distinguish from that. Last time we were talking about included is between the two angles, or the angle between the two sides. All right, rotate this one. So what do we got? This is 1, 2, 3. This is 1, 2, 3. And this goes 1, 2. Is this 1, 2? Yeah, that's corresponding. Is this 1, 3? Yes, that corresponds. Is this 1, 3? Yes, that corresponds. Angle, angle, side. Congruency postulate. That's why they're congruent. All right, one more. Let's see. Here, here, here. This E comes up here, 2 tick marks. 1 here for D, and 12. So it's going to be 2, 1, 12. 2, 1, 12. All right, check. That's angle, angle, side. Okay, so make sure that you're matching up the title of this video with the title of the problem practice set. This is Geometry Semester 1. It's the 7th unit called Congruence, and it is the 3rd lesson within that called Angle, Angle, Side Congruence Postulate Practice. It is on creatormath.com under the Geometry tab, and hope this helps.